In the next section, we're going to focus on a new way to solve a system of equations. We've used graphing, and we've used the substitution method, and now we're going to use something called the elimination method. And today is going to be the first day on solving by the elimination method. Even though we are not going to use these two concepts that I have here, today we're going to be using these tomorrow and then throughout the rest of this semester. So there's two things that I want you to realize. You can multiply anything you want together, anything, and you can only add and subtract like terms. In order to apply these two principles, let's take a look at the three things that I'd like to multiply. Remember, you can multiply anything you want. So if I wanted to multiply a circle and a star, I could very easily multiply a circle and a star. I could write them next to each other, and my answer would be circle, star. If I wanted to multiply 3 times the quantity 2x minus 3y, I would have to do distributive property and take everything in these parentheses times 3. And if I took everything in those parentheses times 3, I would end up with a 6x minus 9y. I can also take an entire equation times 3. Remember, you can multiply anything you want. So that means I'm going to take everything times 3. So I would form a new equation. 6x minus 9y equals 15. And that would be a new equation that I would have to work with. So you can multiply anything together. You can only add and subtract like terms. And we're going to use that concept as we go through the rest of this semester. We're now going to solve two equations using the elimination method, and if you notice, I said that these are supposed to be easy problems. You can tell, if you take a look at number 1, you can tell that you cannot use the substitution method, because if you could use the substitution method, one of those equations would be written as x equals something or y equals something, and we don't have that in the first equation. Remember from the last slide, you can only add and subtract like terms. So let's see if we can eliminate something, because that's what the elimination method means. If I add together a positive x and a positive 5x, I would get a positive 6x. That doesn't eliminate. If I add together a negative 2y and a positive 2y, that would give me 0, and so the y's would be eliminated. So that's exactly what I want to do. Let's add these two equations together. So if I add positive x and positive 5x, I get positive 6x. If I add a negative 2y and a positive 2y, I get nothing. So don't write anything. If I add a negative 19 and a 1, I get a negative 18. This is now a one-step equation. So divide both sides by 6, and I would get x equals negative 3. I'm halfway done. So now what I need to do is plug x equals negative 3 back into one of those two original equations. You decide whatever one you think's easier. I'm going to plug it into the top just because. So I'm going to have negative 3 minus 2y equals negative 19. This is a two-step equation, so let's just be careful solving this two-step equation. I'm going to add 3 to both sides. And if I do that, I'm going to have negative 2y. Be careful with the negative sign. If I add together a negative 19 and a positive 3, I get a negative 16. Then I'm going to divide by negative 2. And so I will get y equal to positive 8. What I am really finding here is if I graphed these two lines, this is the point that they would intersect. So I think it would be better if we just wrote our answer as an ordered pair, and I'm going to write my answer as the ordered pair negative 3, positive 8. So this would be the best way to write the answer. Let's try to do number 2 using the elimination method. I want to look and see if anything would eliminate if I add these equations together right now. And hopefully you notice that if you added these two equations together, the 3x and the negative 3x would add up to nothing. So let's add them together. 3x and negative 3x is nothing, so don't write anything. 1y plus 2y is 3y. And if I add together a negative 2 and a positive 14, I get positive 12. This is again a one-step equation. Divide both sides by 3, and I get y equals 4. I'm halfway done in this problem. I'm going to plug y equals 4 back into whatever equation I think's easier. I think the top equation looks easier, so I'm going to plug y equals 4 into the top equation. So my top equation is going to be 3x plus, instead of y, I'm going to replace it with 4, equals negative 2. And now this is a two-step equation that I should be able to solve. Let's subtract 4 from both sides. So I would have 3x equals negative 6. And then if I divide both sides by 3, x is going to be equal to negative 2. Again, if I graph these two lines, that is the point where they would intersect. And so I think it's best to write our answer as an ordered pair. So my answer for this one is going to be the coordinate point negative 2, positive 4. And that's an example of solving two equations by the elimination method where something would already eliminate if you added the two equations together.